Let's start with 6.1. Is there any question you want me to go over? I think the fact that a function to have an inverse, well, maybe I think I write it more precisely. Note. First, every function has an inverse. But only one-to-one functions have an inverse that is also a function. Okay. In 6.1, it was mentioned that if you were asked to find the first derivative, the derivative of inverse function, then the function has to be one-to-one. Now, what happens if it is not? Do you not get an answer? The answer is you will get multiple answers. Okay, to be more precise, the following: f inverse x is the notation for inverse function. Okay, of fx. And this fx has to be one-to-one. Now, what happens if the function is not one-to-one? Now, if the function, if fx is not one-to-one, then the inverse is not a function. And therefore, does not have the right to use this notation f inverse x. Okay, f inverse x is inverse function, so it has to be inverse and a function. You see? Okay, so let's see an example. For example, fx equals to x squared minus 4. Now we know this function is not one-to-one. Okay, it's not one-to-one. Right? Now, does it have an inverse? Yes, it has an inverse. Is the inverse a function? No, it's not. Okay, so find the inverse. So I can ask you that question, find the inverse, And we do it with step 1 to 3. Step 1, you change the fx becomes y. Step 2, you swap x and y. And the inversing actually happened here. When you swap the x becomes y, y becomes x, that's the inversing. Now then step 3, we try to isolate the y. X plus 4 equals to y squared. So y equals to plus minus square root of x plus 4. Okay, so you see that for some x's, actually most x's, you will have two different y's. Therefore, we have no right to use functional notations for that. We cannot use this. But this is the equation. This equation is the inverse of that function. This is the inverse of fx, but it is not a function. Now, I think the reason I emphasize this is because a lot of students, even though they come to calculus 2 already, which means they already passed calculus 1, a lot of you still have that misunderstanding that an inverse has to be a function. No, that's not true. An inverse doesn't have to be a function. Okay, and this notation only reserved for an inverse, which is also a function. Okay, so we may have an inverse, which is not a function. Okay, yeah. Yeah, every function has an inverse, but only one-to-one function has an inverse that's also a function. In fact, if f is one-to-one, then the inverse function is also one-to-one. Okay. Yeah. Once any of them not one-to-one, then the inverse is not one-to-one. Okay. That's important to say. A second, one way to show one-to-oneness is by showing that the function is continuous and monotonic, strictly increasing or strictly decreasing, except at some singletons or some points. Okay, I have a chat coming in. Is this lecture recorded? As I remember, yes, yes, it is recorded. Okay, now then to show that the function is strictly increasing or decreasing, one way to do it is to show that the first derivative of that function is strictly greater than 0 or strictly less than 0, except at some points. By the way, strictly increasing or strictly decreasing only is not enough. It has to be continuous also. Okay, it has to be continuous also. Now, one very classic example of a function that is strictly increasing, but not one-to-one, is the tangent function. Tangent function is strictly increasing, but you know it's not one-to-one because it's discontinuous at some point. Okay, so the continuity has to be maintained. I think my line. The continuity has to be maintained. Okay, so for example, this tangent is one-to-one between negative pi over 2 to pi over 2. Why? It's strictly increasing there and continuous. Okay, but it is not one-to-one between negative pi over 2 to 3 pi over 2. It's not one-to-one. You can see here, it's not one-to-one because it intersects the graph. One horizontal line intersects the graph at two different points, right? But the cause is because even though it's strictly increasing, it is not continuous. Okay, so you need two things. You need to have that function to be continuous on that interval and strictly increasing or strictly decreasing also on that interval. then the function is 1-to-1 on that interval. Any other conceptual question?
Nope.
No? Okay, so the answer to answer that earlier question, that when you need to find the first derivative of the inverse function, that the function has to be 1-to-1. Now, what happens if it is not, the function is not 1-to-1? Then we cannot find the derivative of the inverse function. We cannot find the first derivative of inverse function because there is no inverse function to start with. Okay, once the original function is not 1-to-1, then no inverse function. You have inverse, it's not a function. Okay. Now, if you have no more question, then let me start working on some problems. Is there, you have your book, right? Let me ask you to take a look in your book. Is there any problems you want me to go over? Number 45. Let me see, number 45. Oh, that one is a good one. Let me write it down first. Number 45. I know some of you have solution manual, but don't rely on your solution manual though. Okay, and then also don't rely on Slater. Some of the answers actually are bad answers. Try to work on your own. Okay, what makes your feet stronger is by doing the exercise. And sometimes the hardest part is really, what do you do first? Okay, what do you do first? Number 18. If fx equals to x to the fifth plus x cubed plus x, then find inverse function at 3 and the value of f inverse 2. Okay, the first question I think is quite easy. The second question, the second part is actually a bit harder. Number 35 and 37. Let me collect them first. Okay, the first question, part A, what is f inverse 3? Part A, f inverse 3 equals to what? Solution. Let f inverse 3 equals to x. Let's call that x. Now, so basically, if the output is 3, what is the input? Right? That's basically the question. That's inverse direction, like that, right? Okay. Now, in other words, fx equals to 3. Find that x. Is it right? That notation means fx equals to 3. And so for x. So x to the fifth plus x cubed plus x equals to 3. Because it is 1-to-1, just guess it.
It's
okay?
1.
Just 1. Okay, why do we just guess it? Because it's 1-to-1. Once you get an answer, that's the answer. That's the nice thing about 1-to-1ness. There's no such thing called a wife of Thomas, right? Okay, there must be the wife of Thomas. Okay, if you can find an answer, that's the answer, and it only applies to 1-to-1 function. So from here, don't try to solve it though. I think if you try to solve it analytically, it will take you forever. I don't think I can do it though. So then x equals to 1. So inverse function of 3 equals to 1. Now part B.
I think that's why I got the part B wrong, was because I guess I didn't pay attention to where it says the inverse is actually 2, and I put the answer for the inverse 3 equaling 1.
Mm.
I was confused about that, but now that I'm looking at it, I'm like, oh, okay. But still, continue.
Okay. Yes. Is it right to say that one-to-one function has only one answer? Yes. Yes. That's a nice thing about one-to-one function. Okay. To be more precise, it has at most one answer. It has at most one answer. Okay. It is possible you have no answer at all. Remember, like for example, exponential function. Exponential function is one-to-one. Right? But there's no answer for y equals, there's no x for y equals to -3, for example. Right? You see what I mean? One-to-oneness guaranteed that if you have an answer, there's only one answer. Okay? But if there's no, it is possible there's no answer. Okay? That's very, it's more into conceptual question though, by the way. Okay, glad that you asked that, otherwise then I have to remind myself to remind you. Okay, now, at most one answer to be more precise. Okay, now part B, this question is actually a bit tricky. Okay, so function of f inverse 2 equals to what? Now, if you think about it, let's see the following. So let's say this is x and this is 2. Okay, this is the function fx. Okay, now this is the inverse function of 2. Okay, so using this diagram, you can see inverse function of 2 is x, right? Now the function of x is 2. Basically, the function and inverse function cancel each other. Does it make sense? Okay, but hold on. I have some reservation on that. Okay, but we need to make sure something. We need to make sure that 2 is in the range of the function. But need to make sure that 2 is in the range of the function. Okay, and we can easily show that because the function coming from your pre-calculus or college algebra, right? Shane, you took my college algebra. Okay, so this is x to the 5th plus x cubed plus x. Because the degree is odd, degree of fx is 5, which is odd, then the range will be all real numbers. Polynomial of degree 5 will have far end behavior from -infinity to infinity. Either it looks like that or it looks like this. Now, but it relies on your pre-calculus though. Okay, your pre-calculus, when we learn polynomial, if your polynomial is degree an odd degree, then the far end behavior must be opposite, -infinity to infinity or +infinity to -infinity. So this way it guarantees that 2 is in the range. Okay, so 2 is in all real number, which is the range of the function. Then we can say, so the value of the function at inverse function of 2 must be 2. Now, let me show you the situation where it doesn't work that way. Okay, so suppose I have let fx equals to 2 to the x. Notice that the range of this exponential function is from 0 to infinity, right? Okay, now then find, suppose I change do ask this question, find the value of the function for inverse function of -2. Okay, now the answer will not be -2.
Because the range is between 0 and infinity.
That's right. Okay, so do not get tricked and say that to say that the function always cancel inverse function. It is not true. It's not true. Why? Because f inverse of -2 is undefined. In other words, there is no x. There is no real number, no x, such that fx equals to -2. Right? So in other words, we cannot ask what happened if you push that x using a function. The thing is, there's no such thing called -2 here for you to even go back into the domain. You see what I mean? The 2 is not in the range of the function because, I'm sorry, -2 is not in the range of fx, but we know the range of fx for a one-to-one function is equal to the domain of the inverse function. Right? Okay. So if -2 is not in the domain of the inverse function, then this will be undefined to start with. Okay, this person is dead on arrival. Okay, so there's nothing that you can do here not to say that what happened to the function. Okay, so as easy as this part B question in our original question seems like, more things to actually mention that we need to have that requirement that the 2 has to be in the range of the function. Now then, how do we show that 2 is in the range of the function? Now just then you need to go back to your pre-calculus that this function is a polynomial with odd degrees. Therefore, the range is all real numbers.
If the degrees were even, what would that mean?
It won't be one-to-one. Right? Because an even function, an even polynomial must have the same far ends behavior either from the top to top, like x squared or x to the fourth, or bottom to bottom. So it's not one-to-one right away. But they can actually make it one-to-one by restricting the domain. You see? So x squared, for example, is not a one-to-one function. Okay. For example, fx equals to x squared is not one-to-one. Is not one-to-one. But if they restrict the domain, let's say fx equals to x squared for x less than equals to -1, then it is one-to-one. So one way to make a function to be one-to-one is by restricting the domain. Okay, now in that domain, restricted domain, then you will see the function should be continuous and the first derivative is strictly negative or strictly positive, except at some point. Okay, so this number 18, part A is actually an easy question. Part B is tricky. I mean, you see that I can just answer it like in one line like this, right? Okay, but the detail is the devil. Yeah, the devil is in the detail. In other words, I can easily find a question where you cannot answer that way. Like this one, the one I show you here.
You have to basically prove that your answer is correct.
You need to remember what are the requirements for this to be equal to 2.
Okay.
Okay, that's for number 18. Let me go on to number 35.
So for part B, we also have to prove that it's uh, continuous and one-to-one, right?
No need, because they already used the notation of F inverse. They already used the notation of F inverse. It means the one-to-oneness is already being assumed, even by them.
Okay.
Okay, what we need to show is only that 2 is in the range of the function. That's all we need to show. I mean, nothing wrong if you want to show that also that the function is one-to-one, but there's no need because they already say implicitly that it is one-to-one. Right? Okay, the only way you can have inverse function, F inverse, is when the function is one-to-one. That's the only way. So if they use that notation, then I don't need to show that they can use the notation. They already use it. Okay. Number 35. We have fx equals to x cubed, a equals to 8. There are many parts of this question. Part A, show that fx is one-to-one. Okay, solution. First, fx equals to x cubed, which is a monomial, which is a polynomial, right? So fx is continuous. On all real numbers. I have a chat coming in. No, you cannot just show the graph. No, because the graph that you show me may be only part of that, right? You only show me from -10 to 10 maybe, and it turns out to be not continuous at 100 when x equals to 100. No, no. Graphing it is not a way. Okay, yeah, graphing is not a way. So that we show continuity. Second, I do the derivative. So the derivative of x is 3x squared, which is greater than 0, right? X squared is 0 or positive, right? Greater than 0, except that, hold on, I think I prefer to say it this way. Greater than 0 for x not equals to 0 and equals to 0 for only one point x equals to 0. Okay, so this function is strictly increasing except at one point. So the function is increasing. Therefore, the function is one-to-one. Now, either it is increasing or decreasing. Okay, it doesn't have to be just increasing, but not increasing and decreasing, like not increasing and decreasing. Now, this is not one-to-one. Okay, it's only increasing or only decreasing. Okay, so that's to show one-to-oneness. Part B, use theorem 7 to find. So part B, find the derivative of the inverse function at 8. So what do I need to do first? I need to find inverse function of 8. Inverse function of 8 equals to x.
Does it always equal to x?
Huh?
Does it always equal to x?
I just call that x. So you can call that in something else. You can call that y, you can call that b, you can call that p. I just define a variable so that I can use that variable fx equals to 8, like that.
Okay.
Okay, so x cubed equals to 8. That means x equals to 2. Okay, now that's the first part. The second part is to find the derivative of the function f prime x equals to 3x squared. Okay, now then according to that theorem, the derivative of inverse function at 8 equals to 1 over the derivative of the function of inverse of 8. Is it right?
Mm-hmm.
Okay, now then this is equal to 1 over the derivative of the function at 2, which is 1 over 3 times 2 squared, that's 1 over 12.
Okay. Oh man, that was so easy, and yet I don't know why it felt so complicated.
Okay, so basically, if you look at the theorem or the formula, right, the derivative of the inverse function at x is the reciprocal of the derivative or the slope of the function at the inverse of that x. That's actually the formula. Okay, so the way I did it, I actually did this first. I did that first.
Right.
Okay, then after that, I find this.
I think my issue was I forgot to do the antiderivative. So
Oh, you need to.
yeah, exactly. So when I went down to it, I'm just like, wait, is it still 8? I was so confused.
Yeah, and somebody make a comment that writing down the formula first actually helps. Yes, it is. It is almost always true. Put it this way: it's never wrong to rewrite the formula first. Then you start plugging numbers, because what happened to you, just the one who just spoke, who spoke just now, what happened to you is that you may get the numbers right, but you plug it into the wrong position.
Right.
Okay, right?
And
So
that's usually like the mistake that well, at least I do when
you are not alone.
alone.
Now, the good thing and the bad thing is that you are not alone. Okay, the bad thing is you are not alone means that a lot of people make that mistake. That's bad. Okay, the good thing is we can easily identify that, and that's an easy fix for that kind of mistake. Write the formula down first, and then you plug in numbers.
I think it's also too like the winter semester, like not practicing this. You kind of tend to forget of something fall in the cracks.
You know what? Things like that happen.
Right.
Right? Hey, math is something that either you use it or you lose it.
That is so true.
Right? Okay, so if you don't use it, like people who took calculus 1 like years ago, I saw from some of you, like if you took calculus 1 from years ago and you don't do math in between, then you will have some hard time. Okay, I'm not telling you to drop the class. Okay, no. In fact, dropping the class is just a wrong solution. No, if you have not done math for a long time, what is the best way for you to catch up? Okay, push yourself to keep on studying. At the beginning, it will be quite tiring, overwhelming, and frustrating, but basically, the best way to overcome brain freeze is by burning it, to defrost that. Now, the defrosting process may hurt, but that's the only way. Okay, that's the only way. Yeah, I'm when I say burn it, in a sense like the allegory we use, like brain freeze, right? Yeah, I mean no brain can freeze. So of course, when I say burn that, it's basically to defrost that, not literally, okay, but the fastest way to make your brain can flow with can think freely, the thought can flow is by actually defrost that, to burn it, melt it as fast as possible. And it is by like just expose yourself to those things. Okay, so for those students who have not done math for quite a while, you know what, it's quite frustrating, but keep on working on that. Okay, yeah. And group study will be helpful to keep yourself afloat. Okay, I mean, I was there before. I was there when I'm done with my bachelor in year 1999 October. I'm done with my bachelor. I think I did very, very well back in Indonesia. And then when I came to America, I was one of a few people who were lucky enough to get a green card lottery. And then, but I came from a very poor family, so I didn't have in mind that I would continue with my master's until somebody told me, Thomas, you can continue with your master's, you can get student loan at least, but there's a lot of financial aid out there, and give it a try. And this is the funny thing. The friend who told me that Thomas gets student loan, I said, well, when I compute, I need 20K to finish my master's, right? And he actually gave me this idea. You have green card, right? So you're not a citizen. Yes. So think of it this way. Imagine if after you get your master's, right? Okay, you have 10 years to pay for this 20K. It means every year you need to pay 2K. Every month, let's say you need to pay $200. Do you think you cannot do it? I say $200 is something I can pay even right now. At that time, I was working, I worked full-time at church and also at the bank. So I worked full-time job at the time. Right? Can you pay $200? I say, yeah, even right now I can pay $200 per month. And then, so he said this, then how terrible you must be if after your master's degree, you still cannot pay $200 for 10 years. I say, yeah, that makes sense. And then he actually said this also, but you know, even if you cannot pay it off, you know what to do? I say, no, go back to Indonesia, just run away. I say, what the hell? So if you cannot pay back your student loan, you run away. I said, well, that's the privilege of being a green card holder, huh? Instead of citizen. So that's actually encouraging me to start my master's. Honestly, if he didn't say that, I have in mind, no, 20K is too heavy for me, because at the time I worked like $8.50 per hour. Okay, and in my mind, I will never be able to pay off even a $5,000 loan. You know, I mean, those numbers scare me. Coming from a poor family in a poor country, suddenly come to the United States alone. You know, so oh, come on, man. No, it's not even in my mind. And he said it that way. He said it that way. Say, you know what? Even if you cannot pay it off, just run back to Indonesia. After all, you must be a very terrible person. No, not that very terrible for not being able to pay that, but it is a reflection of who you are, Thomas, if you cannot even pay $200 per month. After having your master's degree, come on, man, tutor for 10 hours, you already get that money back. You simply just don't want to do anything to let it happen. Well, anyway, I need to come back to this. Okay, part C. So part C is a more not the standard way, an old way to do it. Calculate inverse function of x. So we have that fx equals to x cubed, right? Okay, so how to find the inverse function? So step one, I need you to show me this work though. Okay, step one, change fx becomes y. Second, you swap x and y. And step three, you solve for y. Now, when you solve for y, then you ask yourself, is this define a function? If it is define a function, then you can rewrite that, replace the y by inverse function. Okay, notice that in my early example, which one is that? The x squared example. Yeah, in my early example here, notice that in my step 3, y equals to plus minus something. Okay, I cannot go to step 4 because this y does not define a function, right? So I cannot go to step 4. I stop at step 3. If it doesn't define a function, then you cannot write it as an inverse function. Now we can. Okay, and state the domain and range of inverse function. Well, we look back into the function fx, the domain of fx. You know what? I need to use the original color fx. So domain of fx is all real numbers, right? It's a polynomial. But at the same time, we know the domain of fx is the range of the inverse function. Now, likewise, what is the range of the function? The function is monomial with degree of 3, right? So the range must be all real numbers. Therefore, the domain of the inverse is also all real numbers. Now, you can use negative infinity to infinity in place of all real numbers. Either way, it's okay. Now, part D. Part D. Now, calculate the first derivative of inverse function of A. So if I don't use that theorem, if I don't use that formula, then this will be, the derivative of that will be x to the 1/3 becomes 1/3 x to the negative 2/3 at A. So this is 1/3 times the cube root of A squared. Okay, now my A is 8. So this is 1/3 times the cube root of 8 squared. That's 1/3 times the cube root of 64. That's 1/3 times 4, which is 112. Now you see that it matches with what we have in part B. Okay, now sketch the graph of fx and f inverse x on the same axis. Okay. You know what? Let me use this instead. Okay, let me show you this. Okay, so the first one is y equals to x cubed. And then the second equation, y equals to the cube root of x. I draw them on the same axis. Let me do the screenshot here. Because I have something I want to say. At least then you can imagine that visually, why we have that reciprocal. And I believe I mentioned that in my lecture, though, my lecture video, but let me emphasize that again here. Okay, so my graphing software have the weakness of not able to graph the cube root nicely, like completely, to be more precise. Okay, so it should be something like this. Okay, now then, what happened is this. The first derivative of inverse function at A, okay, so let's say this is my A here. Let's say this is my A. The first derivative there is basically asking us what is the slope, right? What is the slope? That's the same. Okay, now then, the way the theorem works is actually the following. Now, if f inverse A equals to B, let's call that B here, let's call that B, then FB is equals to A. If this is B, then this is A. Okay, F inverse A equals to B implies FB equals to A. Is it okay? Now, the thing is, because of the inversing property, okay, then the slope must be the reciprocal all the time. The slope here, the one in blue, the slope here must be the reciprocal of the green one. Okay, so the slope of the green one, okay, is equal to 1 over, let me call this M1 and this is M2. Okay, it's always the reciprocal of M2. Okay, now what is M2? M2 is the slope of the function at B, right? But what is B? B is the inverse function from A. That's how we get that formula. Okay, you can try, let's do the simple one to show the fact that the slopes of two inverse functions are reciprocal at the corresponding coordinates. Okay, for example, let y fx equals to, I hope this is simple enough. Fx equals to 2x minus 1. What is the slope here? 2. Okay, now the inverse of this function must have slope 1/2. Okay, now if you do the inverse function, you will see f inverse x is actually 1/2 x plus 1/2. Okay, now then you see that the slope is the reciprocal of the original one. Okay, now that's if it is line. Okay, so the slope everywhere is of a line must be the same. Okay, so the inverse function of that linear function must have constant slope also, which is the reciprocal. Now then, what happens if the function is not linear? Then, for example, the slope here, okay, the slope here corresponds to the slope here. Okay, the slope here is the reciprocal of the slope here. The product must be 1. Now, distinguish that from perpendicular. If two curves are perpendicular, then the slopes must be, the product of the slope must be -1. Okay? Now, that's the little explanation from, I think I'm done with part E. That's for number 35. Number 37, yeah, number 37 is not 1-to-1, but becomes 1-to-1 because they restrict the domain. Okay, so fx equals to 9 minus x squared, but the x is only from 0 to 3. And the a is 8 again. Okay, that shows that the function is 1-to-1. So part A, fx is 1-to-1. Why? Proof. First, fx is a binomial. And therefore this polynomial So fx is continuous. On all real number, and consequently it must be continuous on this interval. That's 0 to 3. It is actually continuous everywhere, but because they restrict the function to be from 0 to 3, then I just need to show that the function is continuous from 0 to 3. Second, the derivative of the function is negative 2x. Okay, which may be positive, may be negative. Okay, but this will be negative or 0 on that interval 0, 4, 3. Okay, so f prime x equals to 0 when x equals to 0. Only at one point that it is equals to 0. For the rest of that, it is negative. Okay, that way then fx is decreasing on that interval 0 to 3. Consequently, and together those two, so this guy and this guy by 0.1 and 0.2, fx is 1 to 1 on 0 to 3 on that interval. Okay, part B, and use the theorem to find f in derivative of f inverse at 8. Solution: find the inverse function first. So step 1, inverse function of 8 equals to what? Let's call that x. Let this inverse function equals to x. Then fx equals to 8, which means 9 minus x squared equals to 8. And then we solve this equation, right? X squared equals to 1. So x equals to plus minus 1, right? Okay, but which one do we use? We use the positive. Why? Why do I use x equals to 1 and not x equals to negative 1? Why do I don't use this one? Why do I reject this one?
Because our interval is 0 to 3.
That's right, because this is not in 0 to 3. Okay, then second, what's the derivative? The derivative of x, oh, we did that earlier, that's negative 2x. Right, so the derivative of inverse function at 8 will be the reciprocal of the derivative of the function at inverse function of 8. Okay, this is 1 over the first derivative of the function at positive 1. But that is 1 over negative 2 times 1, that's negative 1/2. Okay, I have some chat coming in. Yeah, it is within the range. Okay, I don't think I will do all of this, but finding the domain and range is actually quite interesting. The domain and range. So fx equals to 9 minus x squared on that interval 0 to 3. Okay, so because the domain is 0 to 3, then the range of inverse function must be the same to the domain of the function, right? Has to be. The domain of the function equals to the range of the inverse function. The hard part is what is the range of the function to start with? What is the range of fx? When x equals to 0, the y is 9. And when x equals to 3, the y is 0. Now, this will then be the domain of the inverse function. Okay. Now, for part D and part E, you do it yourself. Number 45. Number 45. Fx is an integral from 3 to x of square root of 1 plus t cubed dt. Find in the derivative of inverse function at 0. Okay, so the first part is we need to find what is the inverse function at 0. And call this x. That means fx equals to 0. Okay, fx equals to 0. But this also means that integral from 3 to x of square root of 1 plus t cubed dt equals to 0. Now notice that the integrand is non-negative. It's square root of something, right? So the area under the curve cannot be negative, agree? Since square root of 1 plus t squared is actually strictly positive, it's at least 1, right? Okay, it's basically, it will not be 0. So the integral from 0 to x square root of 1 plus t cubed dt can only be 0 when x equals to 1. Or t cubed. Thank you. When x equals to 3. If you change this to 3, the integral from 3 to 3 must be 0 in every case. Right? In every case.
Can you explain that?
Yeah. Integral from a to a or of whatever function is always 0.
So x is equal to 3. Oh, I see, because it's equal. Okay, yeah, okay.
Yeah.
'cause the
So imagine it this way.
zero.
Yeah. If we look for the area of this non-negative function, the function is non-negative. So let me use this. So the function is non-negative from 3 and square root of t cubed. Let's say it's like this. Okay, let's say that's the function. That's what the curve looks like. This is the square root of 1 plus t cubed. Okay, now what is x such that the area under the curve is 0? It's a tricky question, right? But the only way that the area under a curve will be 0 is when x equals to 3, right?
Yeah, that makes
Okay.
sense. Yeah.
So then, with that said, then, so f inverse 0 is equal to 3. Second, how about the derivative of fx? That is the derivative of the integral from 3 to x of square root of 1 plus t cubed dt. But this is we use fundamental theorem of calculus, right? Derivative of antiderivative. This is equals to square root of 1 plus x cubed, right? Okay, take a look on your calculus one. But using these two, then we can go on with then the derivative of inverse function at 0 will be 1 over the derivative of the function of inverse function at 0. This is 1 over f prime 3. But f prime 3 is the square root of 1 plus 3 cubed. Okay, so this is 1 over square root of 28. That's 1 over 2 square root of 7. That's square root of 7 over 14. Now, don't change it to decimal though. Leave it like that. Leave it like
Oh my
that. Good question. That's why it is like this reminds you a lot about what we did in the past, even your pre-calculus, your calculus one, right? I think the hardest one to imagine is this one here. How do you get that times?
God.
Okay, how do you get that? And it turns out that, yeah, well, just set the x equals to 0. End of story. That's quite a tricky question. I cannot find, so there's a question, find the inverse function of x plus x to the negative 1 for x greater than 1. Oh, okay, so for example, find inverse function for the function fx equals to x plus 1 over x, where x is greater than 1. I think greater equals to 1 is okay. Step 1, or equal, yeah, or equal to 1. Step 1, I change it to 1. So this is x plus 1 over x, which is basically x squared plus 1 over x, right? Okay, step 2, that's a I'm glad that you asked this because you don't want to see that first time in my test. By the way, I asked that question in my pre-calculus class. So I swap x and y. What do we do next? We need to solve for y, right? Okay, so xy equals to y squared plus 1. So 0 equals to y squared minus xy plus 1. By the way, if you really took pre-calculus from West LA College, your instructor supposedly go over this type of question. It's in our book, even though it's not really in the discussion part, but it was in the question part. Okay, that's the one of the benefit of our pre-calculus textbook. Now then, we want to solve for y. I will use quadratic formula. Okay, so y equals to negative b plus minus square root of b squared minus 4ac over 2a. Is it okay so far? Am I missing something here?
So y in the quadratic formula, you just have it as 1, right?
Yeah, because it's 1y squared minus xy plus 1. Okay, now then, now from here, notice that the domain is from 1 to infinity. Domain of fx is 1 to infinity. Is that right? Okay, but if the domain of fx is from 1 to infinity, what will the range be? At least 2. Now the thing is this. You have the plus minus here. You see that? You have plus minus there. Right? So it may be positive, may be negative, but knowing that the range is the 2 to infinity, maybe I break it down first. So you have 2 possible options here. So y equals to x plus square root of x squared minus 4 over 2, or y equals to x minus square root of x squared minus 4 over 2. Now the thing is, if you use this one, there is a chance that the y is negative. Y is negative for some x. Does it make sense? Okay, but the thing is, our domain is from 1 to infinity. It's not negative. That's why I cross it out. Now, all of a sudden, because of that restriction from 1 to infinity, give us only these words. Then I can go to step 4. My inverse function is x plus square root of x squared minus 4 over 2. Okay. Now, actually, going further, the question was finding the inverse function, right? Find the inverse function. The main topic, actually the main aim of this question is like, can you find the range? How do we find this range? How do you get that times? By looking at that. But you see, looking at something is not a good way to answer, right? It's like, I don't look at Jennifer Aniston and think that, oh, she's the best person to be my wife. That's a bad idea, Thomas. Okay, especially because I don't think she likes math. Okay, I like math. Okay, so how do we know what's the range of this function? Actually, you look at this, and see under what situation this function, this inverse function, will be well defined. The domain of this inverse function will be all the y, all the x, where x squared minus 4 to be non-negative, right? So when we try to solve that, we basically need to solve this. We will get step 1, I find the critical numbers. X will be plus minus 2. Step 2, I do the sign graph. the zeros of the polynomials. This is positive, negative, positive. So the solution for that inequality will be from negative infinity to negative 2 union 2 to positive infinity. Okay, that's the domain of inverse function, okay, which is the range of the function. Okay, but we need to be a bit careful that notice that it cannot be negative. Why it cannot be negative? Because the domain of the function is 1 to infinity. Right? From here you see that, well, it won't be less than 2. Okay, so analytically, we then
About
say that,
1/2 between 0 and 1.
Repeat it again.
What about between 0 and 1?
There is no x that give you 1/2. So basically, fx, even if you don't do that restriction, the range will be from negative infinity to negative 2 union 2 to infinity, even if no restriction, without restriction.
Or
Okay, and actually analytically we did it by doing this. Analytically we did it by doing this. Okay, now the reason why I cancel, so if there's no restriction, we get this thing, right? Now go back. Now, note that, okay, note that f inverse negative 2, for example, so I choose this endpoint here, will give me negative 2 plus square root of 0 over 2, which is negative 1. But this negative 1 is not in the domain from 1 to infinity, right? Therefore, the range of the function is only this chunk. Someone say, I don't think that's why she's skinny. Okay, anyway, this is the end of our 6.1. Let me give myself a little break. Okay, right now is 8:37. 6.2, find the domain of part A gt equals to sine of e to the negative t. The domain for sine is all real numbers, so this can be everything, right? Okay, because it can be everything, then t can be everything also. Okay, of course you don't write it this way. You will say, then the domain is all real numbers. Okay, part B. Gt equals to square root of 1 minus 2 to the t. Well, because it is under square root, then 1 minus 2 to the t has to be at least 0. Actually, yeah, at least 0, because under square root, right? But that implies that 2 to the t must be less than equals to 1. 2 to the t must be less than equals to 1, and therefore t must be less than equals to 0. How do you know, Thomas? Well, how do you know is my last name. How'd you know? Okay, 2 to the t looks like this. Now, y equals to 1 is this line here. Okay, so what is the what is the x, or in this case, what's the t, such that the y is at most 1? And from here you can see that the y is at most 0. Okay, you can also apply logarithm if you want, right? Yeah, you can apply logarithm. So if you want to be more mechanical, then you will say that log base 2 of 2 to the t is less than equals to log base 2 of 1. Yeah, log base 2 is an increasing function, therefore you maintain the inequality. Now the left hand side is then t, the right hand side is then 0. Okay, so the domain is negative infinity up to 0. Okay. You can also write it this way. You can also say that the domain is all the t where the t is less than or equals to 0. That's the set builder notation. But I get used to ask my students to do interval notation. That's for number 16. Yeah, interrupt me with your question if you have any. Okay, what else? Number 24, limit x goes to negative infinity of 1.001 to the x. Okay, because if the base b to the x left, so this some background. Okay, if the base is greater than 0, I'm sorry, greater than 1, then the y is increasing, right? The function is increasing to infinity, right? Okay, in fact, the graph looks like this. The graph looks like this. Okay, but then when you approach negative infinity, it goes to 0 instead. Is it okay? That's for number 24. Let's do an easier question, harder question. Number 28, for example. Limit x approaching 2 from the left-hand side for e to the 3 over 2 minus x. X is approaching 2 from the negative side, so negative x will be approaching negative 2 from the right-hand side. Think about it. So 2 from the left-hand side, right? Okay, so if this is x, right? Now then negative x will be approaching negative 2 from the right-hand side. Agree? Then 2 minus x will be approaching, you add 2, right? Okay, that's approaching 0 from the right-hand side. Now then, 3 over 2 minus x will be approaching 3 over 0 positive. That's basically infinity. Now what is e to the infinity? That is infinity.
understand how you broke it down. I just I feel a little lost.
Where?
um can you just go over it just what I mean, I like I said, I understand, like, you know, x approaching 2 from the negative side. I understand negative x approaching negative 2 from the positive side.
Uh-huh.
So
So what happened here is I add 2.
yeah. Oh, okay. See, yeah, that's where I guess that's where I was trying to figure out if that's where I started getting
Yeah.
confused.
Okay. So instead of playing with the, imagine it this way. Imagine it this way. Instead of answering it that directly, I will say that I will play with the limit. So this is limit negative x approaching to negative 2 from the right hand side of this. That's equals to limit 2 minus x approaching to 0 from the positive side of e to the 3 minus over 2 minus x.
Oh, I see.
Okay, but this is basically, I will use a dummy variable. Okay, so limit y going to 0 positive of e to the 3 minus y over y.
I kind of see what you did. I see.
Okay, so instead of dealing with that expression or dealing with that function, okay, I actually modified my limit condition.
So you basically you broke it down into different pieces.
That's right. Okay. Because our issue is really about, like, well, okay, when x going to negative 2, what will this be? Right? Okay, what will this be? Well, that chunk will be approaching 0 from the right-hand side. Now, 3 over 0 from the right-hand side will be infinity, so 3 to the infinity is infinity.
Ooh, damn.
You never see this technique, I believe. You never see this technique.
I was going to ask you, did we learn this in pre-calculus, calculus, or just basic math?
It's more into pre-calculus way of analysis. Okay, so Thomas, I see a question. Thomas, why did you add 2? Well, because here's the thing. What I really need is actually the expression 2 minus x. I already have negative x. Now, what do I do to negative x becomes 2 minus x? I add 2.
Thomas, I also have a question about this.
Uh-huh.
So like Dorland's, I didn't learn this. I didn't learn it this way at all. And I'm wondering, I know that 0 is different from 0, approaching 0 from the positive, but why wouldn't 3 over 0 still be 0? Why would it be infinity?
Oh.
Or 3 over 0 approaching 0 from the positive.
Oh, okay. Okay. The smaller the divisor, the larger that will be.
Of course, but then you just have 0.
Not
0.
exactly 0 though. It's 0 from the positive side.
Oh, okay.
It's never approaching 0. It's just coming towards 0.
Right.
To be more precise, it's never 0.
Oh, okay.
You happen to say it wrong, but I understand what you mean. You say never approaching 0.
It just gets infinitely close to 0,
yeah,
right?
it's to be more precise, it's never 0, but it is approaching 0.
I guess I understand that concept, but seeing the 0 there makes me think otherwise, I guess, because I'm used to thinking, oh, if there's a 0 in the denominator, that must be undefined. But I guess it's just kind of messing with my brain a little bit.
Put it this way. Let's break it down even further. So your issue is not about the e to that power. Your issue is about, what is this? Limit x going to 0 of 3 over x. Basically, that's your question.
Okay, yeah.
Okay.
We can say it like that.
Now, before I answer this, notice that this x approaching 0 here has 2 sides, from left-hand side and right-hand side. Right? Okay, so let's see the right-hand side first. Limit x approaching 0 from the right-hand side. So you divide by something very small, but still positive.
So 0.0.
Let's say 0.00001.
Yeah.
then it becomes really big, right? The closer the x to 0 from the positive side,
Of
the
course.
greater this quotient will be.
Oh, okay.
Okay, now on the other hand, if I use limit x going to 0 from the negative side, oh, sorry,
Negative infinity.
then that will be negative infinity.
Right.
Okay, so based on that, the left-hand limit and right-hand limit not the same, then this guy will be does not exist.
I think, right. I
Okay,
think,
now the question that we have here is only from one side. Before you go on, let me say this first. Note. Okay, now limit x going to 2 of e to the 3 over 2 minus x is equal to limit negative x approaching to negative 2 of e to the 3 over. You don't have to show it exactly like this. No, I show it this way to explain to you what actually happened. That's approaching 0. Okay, so if I use dummy variable, limit y approaching 0 of e to the 3 over y, this will be does not exist. Why? Because when y approaching 0 there, it's not clear. Well, you have two ways to approach 0. If you approach from the positive side, this becomes infinity. E to the infinity is infinity. But when y approaching 0 from the negative side, this will be negative infinity, and e to the negative infinity is?
negative infinity.
No.
E to negative infinity?
Uh-huh.
Oh, infinity?
No, you say it twice.
0.
0.
Oh,
E to the negative infinity is 0. But anyway, the limits,
Oh,
the
E.
left-hand, yeah, right? Left-hand limit and right-hand limit are not the same. Therefore, the limit going to 0 does not exist.
oh.
Okay, that's why they have to put that approaching 2 from the left-hand side or from the right-hand side.
Right. I think I understand a little better.
Okay.
Yeah, I definitely remember that part, the limit x approaching 0. That one, I do remember that from calculus.
Mm.
I
Now,
hadn't seen it the way that number 28 was though, but that's good to know.
some teachers actually don't explain it this way. They just explain it verbally, and then all of a sudden they say, oh, this guy equals to infinity. Boom. Like that. Which I don't mind. But if I do that, I believe some of you will ask me the same question.
Yeah.
How do you get that? Even after I write it down, you still have issue. Right? But at least when I write it down, your issue is being focused. Thomas, why did you do this? Why did you do this?
Mhm.
Right? Okay. Now that's because I'm chasing this form. Okay. But if I don't write anything and suddenly come up with the answer, you will hate me a lot more.
Oh, for sure.
Yeah, students hate me anyway, regardless. But at least I try to tame you a little bit.
I don't hate you, Arjuno.
Not yet.
I like you. Oh, okay, I took you for Trig, so I know you. You're good. I like you. You're challenging, but you're good.
No worry. I'm kidding you.
I got a question. So from the right, it's approaching infinity, and from the left, it's approaching infinity. But the question was only from the left, right?
That's right.
So we don't need to explain the right?
No need. So the question in number 28 is specifically when x approaching 2 from the left-hand side.
Right.
Yeah, okay. Now, I try to put a note here. What if they forget to put that from the left-hand side notation? Then the answer will be totally different. If they're missing the negative notation here. Okay, so you need to think of that approaching 2 from both sides, not only from the left-hand side. Does it make sense?
Yeah. And at the end, why did you switch 2 minus x to y? And
oh, I just try to show you that because we get used to have y or x approaching 0, right? Instead of an expression approaching 0, you like a variable approaching 0 from positive side. So I do substitution basically there.
Oh, okay.
Just substitution, just a simple
Oh.
substitution. So in other words, actually you don't need to do the last step. You can just jump from here to here right away. I mean, it's pretty clear, right? If 2 minus x, if this guy is approaching 0 from positive side, then the exponent here will be positive infinity, right? And e to the positive infinity is infinity. Okay. That's for number 6, the 28. Okay, let me ask you to take a look between number 31 to number 40. Finding derivative. Choose one problem. Number 31 to number 40. Choose one problem, at least one. If possible, even number. Hey, don't tell me that it's easy. Okay, before
35.
you do it on your own, it's not easy. Number what?
35.
Number 35. 35. Y equals to e to the ax cubed. So y prime will be, now let's look back a little bit. Let y equals to e to the u, then the derivative is itself times u prime by chain rule, right? Okay, so the derivative of this guy e to blah is e to blah times the derivative of blah. Are you with me?
Yeah.
Now then from here I go on further. E to blah, the derivative of blah is 3ax squared. Oh, we are basically done. So this is 3ax squared e ax cubed. It's kind of ugly, but it's okay. It's the right one. That's for number 35. Maybe one more question up to number 40.
Can you do 34?
I can do number 34. I just don't want to do it. No, I'm kidding.
Okay, no, wait, no, not 34. Can you do 33? Actually, that one, 33 looks a little scarier than.
No, that's actually easier.
Oh, really?
Yeah, that's actually product rule.
Oh.
Yeah.
Oh, okay. I see what you mean. What can you
So let me just do it first then.
Okay.
Too bad you have one chance, you took it. So, okay, so the derivative of this function will be the derivative of this guy. You don't have to show it this way though. Okay, I just use the notation first, times the derivative of e to the x, like this, right? Now, if you can skip this step, go ahead. But make sure you use proper parentheses though. This will be 3x squared plus 2 times e to the x plus x cubed plus 2x times still e to the x. Okay, I factor e to the x and then add those guys inside. I get x cubed plus 3x squared plus 2x plus 2. That's number 33. Number 34. So buy one, get one free. Ask one, get another question done. E to the x over 1 minus e to the x. Then the derivative will be quotient rule. Okay, the derivative of e to the x times 1 minus e to the x minus the numerator times the derivative of the denominator over the square of the denominator. Then from there, I clean it up. This is e to the x times 1 minus e to the x minus e to the x times negative e to the x over 1 minus e to the x squared, or something cancel, huh? So this is e to the x over 1 minus e to the x squared.
Thomas, so e to the x will always say the same?
E to the x, the derivative of e to the x is e to the x. Well, because remember the derivative of e to the u is e to the u times the derivative of u. Right? So if you replace that u by x, the derivative of x is just 1.
Oh.
Okay.
Okay. Yeah.
I usually remind my students of this, that there are two functions whose derivative is itself. The first one is 0. The derivative of 0 is itself. And the second one is e to the x. The derivative of e to the x is also itself. Is there other function like that? I don't know. Yeah, I mean, all the combinations of this 0 and e to the x will be like that. Yeah, I mean, that's the observation that worth noting. Okay. Now, how about between number 41 to number 50? Choose 2 questions.
You said 41 to 50?
Uh-huh.
Can you do number 44?
Number 44.
Oh, you know what? Actually, no, don't do that one because I remember you did that in the lecture.
Okay, then something else then.
How about 47?
Number 47. Number 47, y equals to a e to the x plus b over c e to the x plus d. Oh, wow. I don't think this is hard, it's just tedious, right? It's different between hard question and long question. Okay, so the top one will be the derivative of this, the numerator, times denominator minus the numerator times the derivative of the denominator over the square of the denominator. That's a c e to the x plus d. Okay, I didn't share that to other students, but I would like to share with you. My daughter broke my glasses, so I have very hard time right now to see.
So
Oh, I know the struggles.
And the thing is, like, it's an old guy glasses, so it's progressive, right? So I cannot see from far, I cannot see from close.
Oh, that sucks.
Oh man.
I could only imagine. You must have a headache right now.
Kind of, yeah. But I really want to spank her, really. I don't mind somebody calling me child abuse. It's at home, nobody knows anyway. But but at the same time, she's just 1 year old, so she didn't understand what she did. So okay, it's just like even if I say don't do that anymore, she won't even understand. Okay.
She'll just laugh at you and do it again.
Yeah, I say, oh, daddy, you give me a funny face. Yeah, no. Yeah, I cannot live. It's like the worst part. The worst thing to look for is your glasses.
Oh, man.
Right now, what is worse than looking for your own glasses is that knowing that you have no more glasses. Right. Okay. Fast forward. This will be. I skip one step. Okay. So this will be a d e to the x minus d c e to the x over c e to the x plus d squared. I think I can factor that a little bit. You don't have to, but it would be nice. So e
Wait,
to the x. Uh-huh.
So the derivative of the nominator, right? You wrote it as just ae to the x. The b, isn't that, don't we have that as 1? Or is that supposed to be a constant? B and D are supposed to be constant.
B, yeah, B and D are constant. A, B, C, D here are not functions of x. So the derivative must be, you need to see that as a coefficient and constant.
Okay.
Yeah, okay.
Thomas, could you also cancel out the CE to the X plus D early or no?
Which one?
In the second step right above?
The one
Oh, sorry,
here?
the third step, sorry.
The one here?
Yeah, CE.
Can I cancel this?
Yeah.
No,
one of those?
you cannot cancel common term. You can only cancel common factor.
Oh.
Right? It's like this. It's like this. Okay. 4a plus 5b over 2. Now this is not equals to 2a plus 5b.
Oh, sorry, you're right. You're right.
Right? Okay. So we cannot cancel it that way. So this is over c e to the x plus d squared. Now, even though I say you may not need to simplify what you had here to here, it is always a good thing to do to simplify, because you never know how far it can simplify. Okay, put it this way. Imagine if I ask you to do the second derivative. Okay. And if you don't simplify, this will be so effing tedious. Right? Okay, I don't think that's what you want to do. So simplify that a little bit first before you you go on further. Okay, so simplifying is actually also a skill. That's for number 47. Any else? Maybe one more from this number 41 to 50.
Can you do 50?
I can. Number 50. If t equals to sine square of e to the sine squared t. Oh, that's a long chain. Yeah, so that's a long chain of rule, right? The derivative of this t will be sine, oh, I'm sorry. This is sine squared blah, so the derivative will be 2 sine blah times the derivative of sine, right, which is cosine blah. And then you need to still multiply by the derivative of blah. Is it okay? Let me do it this way first. Sine squared u. If y is sine squared u, the derivative will be 2 sine u cosine u times u prime. Is it right? Okay. Now then, I copy paste the first 3 factors, which actually we can simplify a little bit, but I will do it later. Now then, what is the derivative of e to the blah? The derivative of e to the blah is e to the blah times the derivative of blah. Man, that's painful. Okay, so this is, now I want you to realize that you can simplify this to be what? Dorlings.
I know I should know this.
Okay, you better tell me. Otherwise,
It looks familiar. I just don't know what it is. I haven't seen the formula in a really long time.
yeah, so I will curse your trick teacher.
Yeah, you should.
Who the heck is that? By the way, everybody, Dorling took my trigonometry class.
I came
That's
back.
right. That's right. That's a double angle formula. So this is sine of 2e to the sine squared t. Okay, for the yellow part.
Mm.
While then I copy this e to the sine squared t. Now the derivative of 2 sine squared t is 2 sine t cosine t. But we can actually still simplify that part, right? This is sine 2t. So this is sine 2t, that's the blue part, times e to the sine square t times sine of 2e to the sine square t. Okay, remember sine 2 blah equals to 2 sine blah cosine blah. And that blah can be anything ugly, but still would still work the same way. That's for number 50. Let me do number 52. Did I do number 52 in my lecture? I don't remember. Okay, find the equation of tangent line of y equals to e to the x over x at 1 comma e. They are nice. They tell you 1 comma e. They can just say at x equals to 1 and then you need to find the e yourself. Okay, solution. Okay, what is the y prime? Y prime equals to e to the x times x minus e to the x times 1 over x squared. I do quotient rule. And the derivative of e to the x is just e to the x. So this is e to the x times x minus 1 over x squared. So what is y prime at 1 when x equals to 1? That will be e to the 1 times 0 over 1 squared, that's 0. Oh, that's horizontal line. Okay. It's horizontal line, y equals something, so y equals to e. Y equals to e. Now, if you want me to put more details on how I get that, y equals to, I'm sorry, I say e, I wrote 0. Speaking about integrity. Okay, how do you get that, Thomas? Well, the point slope form of equation of line, y equals to m, I'm sorry, no, not like that. Y minus y1 equals to m times x minus x1. Remember that? The coordinate is 1 comma e, the slope is 0. Right? Okay, but y minus e equals to 0, so y equals to 0. I mean, y equals to e. Well, the way I see it's a horizontal line, so y equals to the y component of that coordinate for sure. Okay, I didn't expect that to be a nice answer like that though.
Are you
Okay.
gonna put problems like this in the test?
I did, as I remember, but that's students consider that an easy question though. Put it this way: what is the hard part of this question? The topic of this question is, do you know how to find the derivative? That's actually all.
Okay.
Right? Okay. Once you know how to find the derivative with the coordinate, then you get the slope and the coordinate.
Right, like if you were to change everything to like regular numbers and they ask you the same thing, it would be easy. I guess it's just getting used to seeing what's it called, the e to the x and
Yeah,
all
the
that.
derivative.
Yeah, that's kind of like what I think is the quote unquote the hardest part.
Mm-hmm.
And well, I haven't seen it. I think my teacher kind of brushed on it a little bit in calculus, but not that much.
It's well, it's also practice, I guess. So what you need to remember is the derivative. Actually, from here, what you need to remember only one thing, maybe two things. Derivative of e to the x respect to x is itself. Okay, and the derivative of e to the u respect to x is itself times the chain. From this section, right? Actually, that's all you need to remember. The rest basically review from pre-calculus. Okay, now your issue, I guess, which is common, like when you first time get into this, you kind of like distracted with what you forget about exponential function, especially e to the x. Okay, yeah, but what you really need to remember from those is like what happened with e to the x at positive infinity and at negative infinity. That's actually all you need to remember.
Okay.
For now, at least for now.
But you're right. I
Then
think just practice and seeing it so often, it won't be so scary.
So the winter actually screw you up. I'm kidding.
I know. I'm sure it did. I'm sure COVID did too, and the pandemic did as well. I'm blaming on
yeah. You have some. We have pandemic to blame for everything. You know, but well, on the other hand, you need that winter to actually rest. Also, you know, you can't just do things all day, all year long.
That's true.
Yeah, number 54. The winter I took 12 years ago. Wow, it must be a challenge for you to come back. Okay, but hey, it's doable. It's doable. Number 54, find equation of the tangent line. So the equation is x to the x times e to the y plus y times e to the x equals to 1 at 0, 1. Now notice that this is an equation, and trust me, it's not a function. It is not a function. You cannot isolate y by itself and make it a function, I believe.
Wouldn't you want to do like an implicit difference?
Yes, we do implicit differentiation. So solution.
I remembered something.
That's good. Okay, so I will do the derivative of the left-hand side respect to x equals to the derivative of right-hand side respect to x. Of course, the right-hand side becomes 0. Now the left-hand side, you do product rule. 1 times e to the y plus x times e to the x, right? For this part only, maybe I color it. So the derivative of this gives me this. Okay, now how about the derivative of this? That's y prime times e to the x plus y times the derivative of e to the x is e to the x. Now let's plug in numbers, or you can isolate for y prime first if you want. Okay, but I can plug in numbers right away if I want to. Okay, so 0, 1. So 1 times e to the 1 plus 0 times, I think this should be y times y prime, like that. So e to the y is e times y prime plus y prime times e to the 0 plus 1 times e to the 0 equals to 0. And let me fix this part here. It's product rule with product rule with chain. Yeah, the derivative of e to the y respect to x is e to the y times y prime. Okay, now, but this is e plus 0 plus y prime plus 1 equals 0. So y prime will be negative of e plus 1. Now that's the slope at 0, 1. That's the slope at 0, 1. Now what I need is the equation of tangent line. So the equation of the tangent line will be, well, what's the coordinate? Coordinate is 0, 1, while the slope is negative of e plus 1. So y minus y1 equals to the slope times x minus x1. Oh, okay, so that's y minus 1 equals to negative e. You know what? Let me just leave it like that. Negative of e plus 1 times x. So y equals to negative e plus 1 times x plus 1. Why am I thinking so hard? This is the slope, and this is the y-intercept. So it should be clear. This is the slope, this is the y-intercept. Duh, Thomas.
It could be because you don't have your glasses.
Yeah, it could be. It's just like, well, I focus more in like, what did I wrote? That's it. What else? Yeah, just with the time I have left, let me just go ahead with integral. So for example, let me ask you to choose maybe 3 problems from number 79 to number 90.
Hey Thomas, on that last one, for a test or anything, you would still want us to show the tangent line equation that you did there, right? As opposed to, even though it was, like you said, obvious to you with the
Oh,
slope.
if this one is this one, if you really see that, that's okay. I'm okay with that. I will be so happy to see that. If you
Yeah,
realize
okay.
that this is y-intercept and that's a slope, then this is the equation of the line right away. You don't need to show me this.
Yeah,
Okay.
I was still going along with that because I'm still trying to remember the stuff from Calculus 1 last summer. But I was repeating the y minus y1, blah, blah, blah. So that's how I remembered it. But yeah, I didn't see
Yeah,
that.
if the coordinate here is not y-intercept, then yes, you have to go through these. Yeah. Okay. That's because of this though. When we say y equals to mx plus b long time ago, y equals to mx plus b, the m is the slope, the
Yeah.
b is the y-intercept. So if I already know the slope and the y-intercept, bang, I get that. Right? Okay.
Yeah.
Which I didn't realize earlier. But it's good. If I realized that earlier, then I won't remind you about this, which is a more general case, right?
Yeah. It's good to remember.
Yeah. Okay. Now, any question between number 79 to 90? Maybe 3 questions.
Can you do 79?
79. Okay. Oh, nice question. Number 79. Integral from 0 to 1 of x to the e plus e to the x dx. Okay, because the derivative of e to the x respect to x is e to the x, then the antiderivative will be itself plus a formality constant. Right? Okay, now let's do that one first. I think there's one more thing I need to show you one important thing before I go on further in other question. So this is basically integral of e to the x, x to the e. This e is a constant, right? It's like x squared or x cubed. Remember? So the integral of that will be x to the e plus 1 over e plus 1. That's for the first term. Plus integral of e to the x is e to the x itself from 0 to 1. So when x equals to 1, it will be 1 over e plus 1 plus e minus when x equals to 0. When x equals to 0, that's 0 plus 1. Okay, so this is basically 1 over e plus 1 plus e minus 1. Oh, actually, we can simplify this though. This is 1 over e plus 1 plus e minus 1 times e plus 1 over e plus 1. Now notice that on the top, I skip one step. On the top, I get e squared. Right? Because the 1 with -1 cancel. Yeah. This guy, yeah, this guy is e squared minus 1. Right? Okay, so it turns out to be a nice.
Hey, Thomas.
Uh-huh.
How do you hold all of this in your brain? Like, how do you remember all of this?
Practice.
Ooh.
It's actually, to be honest with you, it's not about remembering the answer or the work. It's more about remembering the procedure.
Oh, like the rules?
Yeah, the rules, and you keep on practicing. And of course, with practice, you also see the common mistake, the tricky part, you know, the sneaky questions, like the one, number 80, actually, a lot of people fall into it badly. Number 80, -5 to 5 of e dx. Now,
You
the
know,
thing,
just by looking at it, you're like, oh, that should look or be easy, but I wouldn't even know how to start.
okay, that's a constant. No variable in the integrand. So this is basically equals to e times, what is the integral of 1? Just x from -5 to 5. Put it this way. Actually, instead of doing it that way, let me do this. I factor the e out. It's a constant, right? No variable. Integral from -5 to 5 dx. That's basically it.
Oh.
Right? And integral of 1 is basically the length of the interval. So this is 10e.
Oh. Damn, tricky.
That's
No, it's not. No, it's not tricky. It's not tricky. Let me tell you this. Okay. Integral from, let's say, -3 to 200 of 2 dx. What
See,
is that?
it's easier to see it that way. It's just that once you
Right?
see the E, it's like everything just goes out the window.
Because e seems like a variable, but it is not.
Yeah.
Right? Yeah. That's actually one issue. Yeah.
Yeah, I can see that because just like I don't know who was it that just said that's it. I'm like, wow, okay.
No, I know. No, trust me. Even I was like, what?
Yeah, e seems to be a variable because it's a letter, right? But e is actually a constant, just like a pi. Just like pi. I should not say like a pi. Like it's like pi. Okay, pi. So integral of -3 to 20 of pi dx. Then you will ask me, Thomas, you never teach us what is pi to the x. No, that's not pi to the x. That's just pi. Okay. Good question. White hen. Do you know white hen already?
Shane got it right.
Yep.
Okay, to be more precise, the following. I would like to mention about the meaning of the interpretation of integral from a to b dx. So the integrand is 1. If the integrand is 1, if you try to picture that, it means the function is 1, right? From a to b. So what is the area under that rectangle? Basically, what is the area of that rectangle? That's b minus a times 1. which is the length of that interval, right? Which is the length of the interval. Okay, so if I, for example, I change this to 3 here, if I put 3 there, then I basically have 3 times b minus a. Okay. Yeah, sometimes some integral easier to answer by kind of like imagining what the graph look like. Okay, I mean, of course, the graph has to be a simple one to be easy to imagine. So this e here, just the coefficient, and this integral here, because the integrand is 1, then it will be just the length of that interval. Okay. If I have a chance to teach you calculus 3, I will show you how integration being developed from number line becomes triple integral. Why do you blame Jesus?
No, I'm calling on him because I need help.
Yeah, as if like. Okay, we have 5 more minutes, 6 more minutes. One more question, maybe.
Number 87. Damn, Shane.
87. Okay. I see a chat coming in. Let me see. 87. Integral of e to the tangent x of secant squared x dx. Oh, this one is one of the easy question which you forget the technique. Substitution, u equals to tangent x. So what is the du? Secant
squared?
Secant squared x dx, right? Okay, so basically it follows the following procedure, which is true in daily life. If you see something ugly, you substitute. Okay, that's why you don't want to be ugly, because you will be substituted. Okay, so this is integral of e to the u du. Ah, that's e to the u plus constant. That's e to the tangent x plus constant.
Wow, that was it.
Mm-hmm. Number 86, I think, is more interesting. At least when I see number 86, I kind of like know what I will do, but not sure. So let's take a look. Oh, you know what? I think that this is, yeah. I think this is what I will do. U equals to 4 plus e to the x. Yeah, because this is the ugly guy, right? So don't you think that that principle, if you are ugly, I substitute you, is a good principle? Yes, Shane asked me, do you care if we add plus c or not? Yes, you have to. That's half point there. Yeah, because it's an indefinite integral, right? So you need to add constant. I would really like to just ignore it, like I don't mind, but then I myself fell into the same issue when I took differential equation. So make it a habit. Now so we cannot add it to just the end. No. Once you're done with your definite integral, you need to plus the constant right away. Okay, it's not something that you adjust at the end. No. Once you're done with the indefinite integral, you need to have add the constant right away.
So when you give us the interval, then we take it off once we substitute, right?
Well, if you have definite integral, you don't need to plus constant anyway.
Okay, so that's why. Right? So you don't put c when you put
the yeah. If you have limits of integration, then you don't need that, but you need to put that. Right? Okay, like the one that I did up there, the one I did here.
And just plug it in.
Yeah. So either you have this or you have plus c. Okay. Good question. That's the little silly things that usually, yeah, I know. That's what I was about to say. A teacher who is fine if you do it only at the end, but now that's not appropriate. That's not appropriate. It's like you yell at me for 1 day long, and then later on you say, I'm sorry.
Mhm.
Right? That's still not appropriate. Cool. Of course, besides saying I'm sorry, imagine if somebody yell at you all day long, and then at the end you say, oh, I'm just kidding. Man, I will do the same thing to you. So I smack you down and say, oops, sorry. I didn't see you. Okay, so this guy then becomes integral. Notice that this is my du,
Mhm.
okay, and this is my u. Okay, so hopefully if anything ugly, substitute that with u. So u to the 5th du. Oh, that's Mickey Mouse. So that's 1/6 u to the 6 plus constant. Then substitute that back. To the 6 plus constant. Okay, the suggested homework from already in my lectures, right? Okay, for 6.1, 6.2, please keep on working on that. So on Wednesday next week, Monday we don't have class. Okay, I mean you can come to Zoom, but I will not be here. But at the same time, actually, I think you can use the Zoom even if I'm not here. I wonder if that's true.
Yeah, we can get on it even if
Yeah, you
you're-
can.
Yeah, so in case that you want to have group study, then go ahead. But I don't think I will go online though. Okay. How do we know if we were doing the suggested homework correctly? You do odd numbers and then check with the back of the book, or that's what I tend to do. But some students try to get solution manual, even though I don't suggest you to do that. Okay, it's better for you to check with your friends like that, or just send it to me. Okay, Thomas, would you mind to check my work? Okay, but of course you organize that though. Okay, and yeah, go to the group. Study group will be helpful.
For your Saturday office hours, should I email you on Friday?
Yes, please email me on Friday for this Saturday. Actually, to be honest with you, this Saturday I don't need to hold office hour though, because it falls into President's Day weekend.
Oh, that's true. That's true.
Right?
Yeah.
But I'll be here if you need me. I'll be here. I was planning to go to Las Vegas actually.
I thought you couldn't gamble anymore.
I didn't say I go there for gambling.
Oh, okay.
Yeah, it's like I want to go to the Bacchanal.
Uh-huh.
Okay. Now you know that when without pandemic, for you to go in there, you need to line up for like at least 1 hour, man. Right? But if you don't have a lot of people there, you go in. You only wait for like 10 minutes, I guess.
Oh.
Yeah.
I haven't been to Vegas.
Not Baccarat, Bacchanal. Bacchanal, the one in Caesar Palace.
Mm.
Oh, you like Baccarat better? Oh, okay. Baccarat, you can lose money and still hungry. Bacchanal, you lose money and full. It's buffet.
Oh, you're funny, Thomas.
Hey, enjoy your life. Calculus 2 is already intimidating.
That's true. That's true.
Right? It's like for a lot of students at West LA College. You know what? I need to stop the recording. Yeah, for a lot of students at West